So I am breaking lesson 5.4 up into two different portions. It'd be a really long lesson if I try to do it all together and might get a little confusing. So we're going to take the first half and just look at how we do what is called substitution in order to evaluate algebraic expressions. Now, once again, evaluate just means to solve, figure out the answer to. An expression is a math problem that doesn't have an answer with it. And algebra just means I can use letters in my math problem. Once again, the key to being able to do this successfully is being able to follow the order of operations. I have to ask for several extra presents. I have to do all absolute value, square root, exponents, and parentheses first. Everything that is separated within its own thing, its own separate math process. Then, once I've done all of that, everything that I should be left with would be my dear Aunt Sally, which would be any multiplication and division that I would do from left to right. And then finally finishing up with Aunt Sally, addition and subtraction from left to right. I must do things in that order in order to get the correct answer. So what is our objective, our reasoning, our purpose of this particular math lesson? So we have our objective, our I can statement of to use the order of operations to evaluate algebraic expressions. So let's go through that once again. I'm going to use the order of operations. I'm going to ask for several extra presents from my dear Aunt Sally. I'm going to evaluate, I'm going to solve an algebraic expression, a math problem that may have at least one letter in it, and it's an expression, so I don't have an answer that it's equal to. Now, when I'm doing these, we're going to start out with examples of where we're told what the variable is equal to. So once again, previous lesson, variables are letters inside of a math problem. We see that we have 4x plus 2, and we need to evaluate, we need to solve. Well, when I see that I have 4x plus 2, then I also have to recognize that that is a variable, a letter, with a coefficient, a number connected to it, which tells us to do what? Previous lesson, multiplication. So that is saying not just 4x plus 2, but that is saying 4 times x plus 2. But then I can see where it says suppose that x is equal to 5. So this x being 5, we call that substitution. Now, in the same way that we know what a substitute is, right? If I'm not here to teach for the day or to teach a math lesson or have a meeting or something, and we get someone to come in and do it for me, then I have a substitute. So we're being told that x has a substitution of 5, or that we're simply going to put the 5 in place of the x. So substitution, make this note, when we are given a value for a variable. Once again, a value is simply a number. A variable, is simply a letter. So once we know what it is, then we will plug it into the problem and then show the math. Okay, so that means I'm going to plug in, instead of having an x, I'm going to plug in the 5. Now I have 4 times 5 plus 2. How do I know what to do first? Well, I'm going to do my order of operations. I don't have any absolute values, square roots, exponents, or parentheses. Therefore, I have to do multiplication and division from left to right. On the left, I see that I have 4 times 5, and 4 times 5 is 20. And so I'm going to add 2 to it. And then 20 plus 2 tells me that it's 22. So the way we would explain this is if I have the math expression or the algebraic expression of 4x plus 2, and I know that x is equal to 5, then the value of that expression is equal to 22. It's a lot of words to tell you that when I solve for x equals 5, the answer is 22. So let's look at this example 1. And once again, when we start doing the assignments, then on the assignment questions, they will often indicate which example from the lesson you can look at to show you the steps on how to set up your math problems. But we'll get to that tomorrow. Let's look at this particular problem. It says evaluate the expression of 6b when b is equal to 1/2. Well, what expression? because an expression is a math problem. Well, it is an expression. Yes, we do have a variable, and yes, we do have a coefficient, but 6b, a coefficient touching a variable, tells me to do what mathematically? Multiplication. So 6b is indeed an expression, a math problem without an answer. So if we know that 6b means the same thing as 6 times b, then I want to substitute, I want to put the 1/2 in place of the b. And when I end up with 6 times 1/2, then I have to ask myself, how can I multiply whole numbers and fractions? Well, that answer is I can't. So I have to change my whole number into a fraction with a denominator of 1. Now I have multiplication that I can do. Once again, I'm going to teach you how to cross reduce. Once again, it's not something that is required, but it will make your life a lot easier throughout this year, but as well as for the next 3 years at least that you're going to be doing math in school. So when I look at 2 and 6, I can see they're both even, therefore I know 2 will go into them. So if I cross reduce 2 by both of them, then I know 2 will go into 2 one time, and 2 will go into 6 3 times. Then I simply multiply my fractions. How do I multiply fractions? I multiply across. 3 times 1 is 3, 1 times 1 is 1, and that just gives me a final answer of 3. Well, what if I don't like to cross reduce? Well, once again, I'm not telling you that you have to. If you want to multiply across and then convert it, then by all means, you're more than welcome to. Well, how do I do that? I simply multiply straight across. 6 times 1 is 6, and 1 times 2 is 2. I have to see the fractions are division. So then you have to put your numerator inside your division box and divide by 2, and 2 will go into 6 3 times. Is that what we got previously? Yeah, it sure is. So therefore I know both ways will get me to the right answer. So I want you to try this next one on your own. Go ahead and do the math and then come back and check with me after you get an answer. Let's see how you did. So hopefully you started and you looked at x over 6. You know that that's a fraction and therefore it's division. And you are going to substitute the 33 in place of the x. And therefore you ended up with 33 over 6. But then you set up your division. So you put your top number inside your division box, you divided by 6. And then as you were dividing, you said, well, I know 6 will go into 33, or you grabbed your handy dandy calculator, you typed in 33 divided by 6, and either one you see that it is 5, because 5 times 6 is 30, which gives you a remainder of 3. Now I like fractions and mixed numbers, so I know that my remainder is my numerator and my divisor is my denominator. But 3 6 I know can be reduced because 3 will go into both of them. If I reduce those by 3's, then I get 5 1/2 as my final answer. But Mr. Barker, I made it into a decimal. Okay, well, it doesn't say specifically which one to do. It started with fractions, so I did end it with fractions, but it doesn't say I can't put it as a decimal, so let's do it. If I have 33 divided by 6, and I'm going to make it a decimal, I still get 5, and 5 times 6 is 30, and I still get a remainder of 3. But if you wanted to use a decimal, once again, it's fine. Then you're going to add a decimal at the end of the number and then bring it up. Then you're going to add a 0 and you're going to bring it down. And 6 goes into 30 once again, 5 times, because 5 times 6 is 30. So you would end up with 5.5. No, they aren't the same number, but they are the same value. So I will give you credit if you put 5 1/2, or if you put 5.5, which is 5 5/10, which is 5 1/2. Moving on to example 2. Now on example 2, it's a little different because I have no numbers at all except for what I have to substitute in, because I have 2 letters. So my expression is, what is x plus y? Well, I don't know, but I can substitute in for the x and y because they tell me what each of those are equal to. If I substitute in for x and I substitute in for y, then I know I have 3/4 plus 2/3. So then I just add my fractions, right? I add across, I have 3 plus 2 is 5 as my numerator, 4 plus 3 is 7 as my denominator. Hopefully you're screaming in your heads, no, that's not how we do it, right? When it comes to adding and subtracting fractions, we have to ask those questions so I know how to set it up correctly. So my first question is, can I even add fractions? Yeah, I can add fractions, right? Well, what do I have to have? I have to have the same denominator, right? Common denominators are important. If I don't have a common denominator, I cannot add, I cannot subtract, I can't even compare for greater than and less than. So I have to have common denominators. Well, if I don't have it, here I don't, how am I going to find it? I'm going to multiply by my opposite denominators. That allows me to change my fractions, and then I can do my addition. So my bottom denominator on the left is what? So 4. So I know I'm going to go to the opposite side and multiply by 4s. And then my denominator on the bottom right is 3. So I know I'm going to carry it back to the front and multiply by 3s. That allows me to get a denominator of 12 because 3 times 4 is 12. And then my numerator, 3 times 3, that's 9. Now I go over to the right, and 3 times 4 is 12. There's that common denominator. And 2 times 4, well, that's 8. Now I bring down my addition sign. Now can I add? I sure can. Now I have my common denominator. Well, what do I do with my common denominator? I simply keep it. Then I add my numerators. 9 plus 8 is 17. That's an improper fraction, right? That's top heavy. And if it's top heavy, then I have to convert it. So my top number gets divided by my bottom number, and 12 goes into 17 how many times? Well, 12 goes into 17 one time with 5 left over. Oh, well, if that's my remainder, then I put my remainder as my numerator, my divisor as my denominator, and so I end up with 1 and 5/12. Can I reduce that? Nope. That's just my final answer. Are we good? I hope so, because now I want you to try this one. Now you have a plus b, and they're telling you what to substitute in for a and for b as your variables. Go ahead and do this math, come back and check. So hopefully you have an answer. We have a plus b, and I know that a is equal to 5/6. I know that b is equal to 3 1/4. So then I'm going to just plug those into my expression. Once again, I'm adding fractions, and I have to go back through those questions. Can I add fractions? Yes. What do I have to have? A common denominator. Do I have it? No. So now you had to multiply by opposite denominators. On the left, you have a 6, so you multiply by 6s. On the right, you had a 4, so you multiplied on the left by 4s. When you renamed your fractions, you got 4 times 6, which is 24, and 4 times 5, which is 20. I don't do anything with the whole number other than keep it, so I just multiply the 4 times 6, which is 24, and 1 times 6, which is 6. So if I keep that whole number of 3 then, and I add my fractions, then I'm going to say that 20 plus, well, that's 26, and I keep my denominator of 24. Well, 26 24ths, I've got to convert that, right, because it's top heavy. So 26 divided by 24 gave you 1, which was 24, and a remainder of 2. And then my remainder was my numerator. My divisor was my denominator. They're both even, so I know I have to reduce that. And hopefully you reduced it using 2s, and you got 1 and 1/12. But hopefully you didn't say that was your answer, because it's not. Because you got to remember that you have that whole number of 3. So when I add 3 to 1 and 1/12, you ended up hopefully with 4 and 1/12 as your final answer. Did you get there? If not, do you see where you made a mistake? If you don't, come and ask me and let me help you. All right, so the final ones that we're going to look at is the idea of plugging in for 3 different variables. Now we have multiple steps here, so we have to follow the order of operations. But my first thing that I need to do is plug in. I need to substitute in with what the values are for my variables. For x, I have a 4. For y, I have 1/2. For z, I have 3. So now I'm going to rewrite my math problem, filling in the values. I'm going to substitute in the values for the variables. So I had 5x, which was 5 times x. Well, now I'm going to plug in the 4 for the x, and I end up with 5 times 4. I was subtracting from that 4y, which was 4 times y, and the math problem tells me that y is equal to 1/2. So then I end up with 4 times 1/2. Notice I brought the parentheses down. It's around that math problem that does not leave until I have solved everything inside of it. Then we're dividing by z squared. Well, z, they tell us, is equal to 3. So now we change that to 3 squared. Then we have to go in through our math. How do we know where to start? We follow our order of operations. I'm going to ask for several extra presents. I'm going to solve all of those things that I possibly can first before I'm left with all multiplication and division, addition, and subtraction. So I'm going to start with 5 times 4. Well, 5 times 4 is 20. And then I'm also going to do 4 times 1/2. So then I know I'm going to have to subtract because that's all inside of parentheses. My final step then will be to do my 3 squared. So I have 20 minus 2, because 5 times 4 is 20. 4 times 1/2 is 2. Starts out as 4 times, or 4 over 2. Then I'm going to divide by my 3 squared. What does 3 squared look like, and how do I solve for my parentheses? Does it matter? Could I do 3 squared then my parentheses? I could. I like to make sure I just continue in the right order, following step by step. 18 is what you're going to get because 20 minus 2 is 18. Then I work on focusing on my 3 squared. So 3 times 3 is 9. If I did 3 squared first, I'm fine, because then 20 minus 2 is still 18. I just want to make sure I keep everything in the correct order. I do that by bringing down my division sign. And 18 divided by 9, if you pick up your handy dandy calculator, but I think most of you know the answer, 18 divided by 9 is 2. Okay? So these problems look really hard. These problems look really confusing. But if I just plug in the information they give me and do my order of operations, it really isn't that difficult. All right, I want you to do this check on your own. This is the last one before I give you some in-class practice. I want you to go through it, pause the video, come back, and let's see how you did. So once again, hopefully you have an answer and you went through the process looking at what we're being told. So we have x over 4, which is x divided by 4, plus 2 times a number touching parentheses and means multiplication, y squared minus 3z. I know that for x, I'm going to plug in for 12, or with 12. For y, I'm going to plug in with 7. For z, I'm going to plug in with 8. So if I have, for the x, 12 instead of x, then I put 12 over 4, plus the 2. For the y, we know it's 7, so that's going to be 7 squared, minus 3z, a coefficient touching a variable, means multiplication. We know for z it's equal to 8, so that's why we have 3 times 8. Now I have to go through my math steps. So inside my parentheses is where I want to start with my focus. So I have z squared, or excuse me, 7 squared. So that's 7 times 7, which is what? 49. And then we see that we have 3 times 8. Well, 3 times 8 is 24. Now I bring down my subtraction. I bring down my parentheses. I bring down my 12 over 4. I bring down my addition of 2. Once again, some of you are wanting to go helter-skelter and do all sorts of math all over the place or go straight across 10. You're getting the wrong answers. Once again, this process of building going down, starting on this lesson, if you don't follow this process, I'm going to start counting your work wrong, because this is a process that is expected that you know how to do, building down and redoing each math problem as you go through it. Next year, 8th grade, freshman year, this is the way we do our math. Now I'm going to focus in on my parentheses. So 49 minus 24 is going to be 25. I bring everything else down. I see that I have 12 divided by 4. So that's all by itself. So I could go ahead and do that before I rewrite my math problem. So if I do 12 divided by 4 is 3, and then I bring down my plus 2, my parentheses of around the 25, then I still have everything left in the correct order. So now I have to focus in on 2 parentheses 25. Once again, a number touching parentheses simply means multiplication. So I'm going to multiply 2 times 25, which is 50. Then I can bring down my addition of 3, and 50 plus 3. Did you get 53? Hopefully you did. If you didn't, do you know why you didn't get 53? Do you see where your mistake is? And if you didn't build it from top to bottom, rewriting your math problems step by step, then I need you to go through your notes and do that correctly, because I'm going to start counting that as points by following the correct steps in order of setting up our math work. But 53 is your final answer. All right, so as I told you, you do not have homework with this assignment, but I do have 3 questions I want you to do in class. I want you to come to me, get this paper, and then do these, and then come back to me, and I'll help you check your work, and if we made any mistakes, we'll figure out where our mistakes are. So come and get this paper, and then you'll be good to go and work on your own.